So remember, this is actually discrete data, but we're approximating it as if it's continuous data. So given 100 trials, and it's binomial, so that's discrete, and I want to find the probability of at least 60 successes. Well, that is written like this: probability that x is greater than or equal to 60, which means probability of 60 or 61 and so on up to 100, which is crazy. You're not going to do all those calculations, although a computer will do it. In fact, I've done this in Excel. But the thing is, this is just too much to calculate, all right? Certainly with a calculator. So as a result, what we're doing, remember I showed that when you have a lot of trials, the bar graphs were roughly the shape of the bell curve of the standard distribution, the normal distribution. So it's kind of like this, and so on. And going back to those bar graphs, they were bar graphs, which means there was a space between them. However, because we're making this into, we're treating it as if it's continuous data, we have to move the bars together. So this is the approximation part. So the bar that represents 60, I'm going to put 60 right there. And the bar that represents 61 starts right beside it. I'll put it right there. And then 62, and so on. And these go on and up until 100. So 60 or more starts with this bar. And because we are letting each bar represent one unit, the 60 bar actually starts at 59.5. So if we're doing 60 or more, we're really starting at the left side of that bar, which means we would use x as 59.5 and plug that into our formula to find the corresponding z value. If I wanted, let's say, less than 58 successes. All right, well, first of all, less than 58 means 57 or less. We're talking about discrete data, so less than or fewer than 58 successes is 57 or less, which means the first bar, so to speak, representing a success is the bar representing 57. And it's less than, so we're going this way. And the right-hand side of this bar is at 57.5. The left-hand side would be 56.5. But since we're including the bar for 57, it starts at 57.5. And that's the x value that we would plug into our formula to find z. All right, so basically identify the first bar that counts in our discrete distribution. And if it's that bar or higher, we start at the left-hand side. In this case, we would use 56.5. And if it's that bar or less, then, as I said here, we would start at the right-hand side and go left. Bottom line is, if this is the bar that is the first bar in our inequality, then we have to figure out which side to use. And that's what's going on. That's where that number comes from. And you will see that in my examples.